For 3.4 video 2, just to finish up those quick examples of solving equations, I have e to the x plus 5 equals 60. I need to get this e to the x by itself, so I'm going to subtract 5 from both sides and have e to the x equals 55. Now I'm at the point where I can't get to the x, it's in the exponent, so I need to change it using our inverse property from exponential to logarithmic. We're base e, so natural log of 55 equals x, and you can leave it there unless you want to approximate it. Then we have log base 3 of 5x minus 1 equals log base 3 of x plus 7. This allows us to use the one-to-one property because our bases are equal. So we have 5x minus 1 equals x plus 7. I'm going to subtract x from both sides, add 1 to both sides, and I have 4x equals 8, divide by 4, and x equals 2. So we're pretty basic equations still at this point, but still using the rules and having to move things around. Then I have something like this. On the last couple slides ago, we had an equation where we moved part of it over to the other side. Now we're here, we have more than two parts. We actually have a whole part here. But I can still move it to the other side because on the left, it is subtraction, which would mean division. But if I added it to the other side, it's multiplication that might be easier to deal with. So then I would have log base 6 of 3x plus 4 equals log base 6, and multiply these two together and have 10x. So at this point, I can use my one-to-one property, and I have 3x plus 4 equals 10x. So I'm going to subtract 3x from both sides then. And I get 4 equals 7x. My pen doesn't want to work all the way. And divide by 7. So x equals 4/7. So before I could start this problem, I had to compress. I could have I could have condensed this on this side if I wanted to and made it a division problem, but I would have to multiply regardless, either one. Okay, so our next one, we have 2 times 3 to the 2t minus 5 minus 4 equals 11. So there's a lot we have to do before we can get to that exponent and get to that exponential function by itself. So the first thing we would have to do is add 4 to both sides. So I have 2 times 3 to the 2t minus 5 equals 15. And then I have to divide by this 2. So I have 3 to the 2t minus 5 equals 15 halves. Now, I had to do all that, so now I can go from exponential to logarithmic form. So it's going to be log base 3 of 15 halves equals 2t minus 5. So I'm just solving for t. I'm going to leave this log base 3 of 15 halves alone for now. So I'm going to add 5 over here. So I have 5 plus log base 3 of 15 halves equals 2t. And then I'm going to divide the whole thing by 2. So t is going to equal 5 plus log base 3 of 15 halves over 2. And I'm done. Oh. Evidently, the alphabet is out of order. We have H, I, J, K, J. instead of L. But anyway. So I have K, this example K, sorry, log of 4x minus log of 12 minus the square root of x equals 2. So we can't, in this case, add over the logarithm because we have this 2 to deal with. Now I could change that too. I could change it because I know if it was 2, it was an exponent, that kind of thing. But I can also just use my division that is shown here. So I have log of 4x divided by 12 plus the square root of x. And here it's really important to use your parentheses because you're taking the log of all of that, equals 2. And since I've condensed that left-hand side, I now can go from logarithmic to exponential form and be able to manipulate this function further. So my base is 10. Since there's nothing there, it's the common log. So I have 10 squared equals 4x over 12 plus the square root of x. Well, I've got to get this out of the denominator. So I have to multiply both sides by 12 plus the square root of x. So I now have 10 squared, which is 100, times 12 plus the square root of x equals 4x. So now I have to, I think I'm going to distribute my 100 just because it's not, I could divide, but 4 doesn't go into, well, 4 does go into it evenly. Maybe I will divide. I'm going to go ahead and divide. I'll try this way. Oops. Went back a slide, or a couple. Okay, I'm going to get my eraser here a little smaller so I don't erase everything I've done. Rid of these. Sometimes there's other things we can do when solving an equation, but we just decide to change our mind a little. So divide by 100 on each side. So I have 12 plus the square root of x equals x over 25. Yeah, I don't know. Maybe it wasn't a smart idea. Probably not, because at this point, I'll have to deal with what I did. Okay, I need to get the x's on one side and everything else on the other. What's causing me a problem is that square root of x, and I don't think that square root of x is supposed to be there. So, since I think I wrote it wrong, because what I need to do next is not something we're quite ready to do, I need to disregard this square root and just see it as an x, so 12 plus x. So let's do this again. So that gives me, sorry about that, guys, log of 4x over 12 plus x equals 2. And now I'm going to go to exponential, so 10 squared equals 4x over 12 plus x. I'm going to multiply both sides by that 12 plus x again. And this time I'm going to distribute that 100 in. So when I distribute that, because this is 100, when I distribute that in, I get 1200 plus 100x equals 4x. I'm going to subtract 4x over and subtract 1200 over to separate the two. So that gives me 96x equals negative 1200. Divide by 96. And x equals, well, I know at least 3 does, right? 3 goes into it. So we got 432. So 4 goes into both of those again. We're just reducing. 8 would go in there too, wouldn't it? So let's do 8. So 8 into 40 is 5 and 0, and then we have 4. And then finally we have negative 25 over 2. It's a really bad 5, but I don't know if I can erase. Sometimes the pen chooses to jump. So negative 25 over 2. So sorry about writing the problem wrong in the initial, so there's no square root there. Okay, now we have this right here. And I want you to think of this problem as it would have been e to the x squared minus 3e to the x plus 2. And then think about it, this e to the x, if I say e to the x equals x, so that would make it x squared minus 3x plus 2, where what I would just do my factoring of 1 times 2 is 2. Factors of 2 that add to 3 would be negative 2 and negative 1. But instead of splitting up this, x squared being x and x, our x is e to the x. So it would be e to the x minus 2 and e to the x minus 1. Again, just thinking about this problem right here being that e to the x equals x, because this would be factored to x minus 2 and x minus 1, but our x is e to the x. So now I have 2 equations here. I need to add over the 2 in this one. So I have e to the x equals 2. This one I need to add over the 1. So e to the x equals 1. And at this point I need to use natural log. So the natural log of 2 equals x. And the natural log of 1 equals x. And we do know this one though, because what power of e will give you 1? And this is one of our rules also, log base anything of 1 is 0. So I have x equals 0 and the natural log of 2. And those are the last examples that we had for today.